Looking at example 1, section 5.1, this is just basically identifying some stuff on a graph. We want to just understand what it means for a function to be increasing versus decreasing. So the question asks, find where the function is increasing or decreasing. I tried to graph it as closely as I could to what you see on the worksheet, at least the important numbers anyway. So what does it mean for a function to be decreasing? It just means as we go from left to right that the function is going down. So the function, as we come in this direction, you see the function is going down there until we reach -1. And when we're talking about the intervals of increase, decrease, it's always x intervals. So the function is decreasing until we reach -1. Okay? So the way we write that, we say that it's decreasing on the interval. We say from -infinity, because it's continuing to go that way, up until we reach -1. Okay, now we're interested to see where else it might be decreasing. We notice that as we pass -1, the function now starts to increase until we reach right about there. And then what happens? Then it starts going down. Okay, so right at and that x value that we're looking at, where that maximum value occurs, so it was increasing, it reaches the maximum, then it goes down and then it starts going down. Right about there is at 2, so it starts decreasing again at 2 until we reach x equals 4, and then right there it starts to go back up again. So if there's 2 intervals or more where it's increasing or decreasing, we used a little union symbol to say that we're talking about 2 parts of a bigger set. So from 2 up to 4, and we want to, there's a little bit of debate about whether we should include them or not. I think this book says that we don't include the endpoints, so we use the rounded brackets. So it's decreasing on that interval. Where is it increasing now? It's increasing, again, we take a look at it and see, we saw that it was decreasing until we reached x equals -1. Then what happened? It started to increase until we reached 2. So it seems to be increasing from -1 up to 2. So -1 up to 2. And then we check, is it increasing anywhere else? Yeah, once we reach 4, then it starts to go back up again. So we put the union symbol, and we say it starts to increase again at 4. And then since that arrow is there, it means it goes until infinity. So again, this is just to sort of be able to look at a graph and decide where a function is increasing and decreasing. A couple of other things that we want to notice here is that when it changes from decreasing to increasing, notice what happens. We have a minimum value there. And then when it changed from increasing to decreasing, we have a maximum value there. And then again, same thing here as we had there. It was decreasing before 4. It was increasing after. So we have a minimum value there. And what we also want to try to remember is that when we have a derivative, when we're talking about the derivative being 0 means that we have a horizontal tangent line. Notice that that's happening right there. We have a derivative being 0. If you imagine what a tangent line would look like there, it would be a horizontal line. So the derivative is 0 there. And that happened to correspond with a place where there was a maximum value. Similar here, and here for that matter, remember that if you've got a sort of sharp point or a kink in the graph like that, that means that the derivative doesn't exist at that place where you see the kink, and that's happening in 2 places here. We've got 2 kinks in the graph. The derivative is not defined in either of those places. And what do we notice? We notice that the graph went from decreasing to increasing. We had a minimum value in both places. Okay, so just make a note of that. It seems that we can possibly have a maximum or a minimum where either, number 1, the derivative is 0 right there, or number 2, the derivative doesn't exist. So that's really what we're going to be talking about for this section, what you'll be reading about. Okay.